This is question number 6 from the chapter 4 agenda questions. They've tried to make life considerably more difficult for us by giving us fractions or decimals. So let's take a look at how we deal with it. The concept is fairly straightforward. We don't like working with fractions or decimals. So before we do anything else, we're going to try to eliminate the fractions or decimals. So let's start with the first one. They've given us 0.2a plus 0.3b equals 0. And we can multiply this whole thing by 10. So times 10. So this will become 2a plus 3b still equal to 0. So that's the first equation. The second one was 0.7a, not plus, minus 0.2b being equal to 250. Again, to get rid of the decimal, we're going to go times 10. So 7a, take away 2b, equaling 2,500. So we've gotten rid of the decimals. We can see that these things are both in the standard form. So we'll just work with 2a plus 3b equals 0, and 7a take away 2b equals 2,500. And we don't have anything we can multiply 2 by to make it equal to 7. So we'd have to find a common multiple, or we could find a common multiple between 3 and -2. So let's work with eliminating b, and let's multiply this equation by 2 and this one by 3. And our common multiple will be 6. So 2 times 2 is 4a plus 6b still equals 0. And 3 times 7 is 21. Oh, I don't know why I put an x there, probably because I'm very used to it being x and y. A 21a take away 6b equal, and this must become 7,500 or 7,500. So now we can add these together. This becomes 25a. This all disappears, and this will become 7,500. So a will be equal to 7,500 divided by 25. 7,500 divided by 25, 300. So that's okay as far as it goes, but let's plug it into the two equations and make sure it works. So 0.2 times 300 plus 0.3b equals 0. So 300 times 0.2 is 60 plus 0.3b equals 0. So 60 equals negative 0.3b. So b must equal 60 divided by negative 0.3. And we'll find out what that is. That would be negative 200, which is fine as far as it goes, but we got to see what it works out to in the other equation. So what did we have? 0.7a, which we're thinking is 300. Take away 0.2b equaling 250. So 0.7 times 300 is 210. Take away 0.2b equals 250. So negative 0.2b equals 250 minus 210, which should equal 40. So what we end up with is b equals 40 divided by negative 0.2, which luckily enough equals negative 200. So this is equal to this, makes us happy. So we like this answer. So our ordered number pair, in this case, we're going to go AB instead of XY, equals 300 negative 200. So if we were to graph this, that's where we're saying the two lines would cross. That's what we mean by solving the system of linear equations. So let's take a look at the second part of this. I got smart and already put it on this page here. Let's take a look at how to get rid of fractions. We've been given 4 over 3b, take away 3 over 5c equals negative 17 over 3. So looks very annoying. And the way we get rid of fractions is by finding a common multiple. That common multiple will be 15. So we'll have something over 15 times b, take away something else over 15 times c equal to something else over 15. So I'll go 15 divided by 3 times 4 equals, this will be 20. And 15 divided by 5 equals 3 times 3 equals 9. Be a negative 9 here. And 15 divided by 3 equals 5 times 17 equals 85. It's a negative 85. So the whole point to putting it over a common denominator is now we don't actually need the denominator. We've just got an equation, 20b take away 9c equals negative 85. No fractions, no decimals. So let's do the same thing for the other equation. What have we got? 5 over 6b plus 4 over 9c equals 5 over 9. So what can we do here? We need a common multiple between 6 and 9, and we'll shoot for 18. We can go something over 18 times b plus something over 18 times c equals to something over 18. So 18 divided by 6 equals 3 times 5 equals 15. And then 18 divided by 9 equals, try that again, 18 divided by 9 equals 2 times 4 equals 8. And 18 divided by 9 is 2 times 5 is 10. And again, now we don't need the denominator. We've got 15b plus 8c equals 10. Oh, that's ridiculous. Let's draw a straight line. So we've now got two equations. 20b take away 9c equals negative 85, and 15b plus 8c equals 10. So as long as we're dealing with b and c being x and y, these are both in the standard form, so that's good. And now we're looking for a common multiple between either 20 and 15 or 9 and 8. So I'm going to look at the 20 and 15 and use a common multiple of 60. So I'm going to multiply this equation by 3 and this equation by 4, but I want one of them to be negative because they have to cancel out. So I'll make this one negative 4. So 3 times 20 is 60b. 3 times 9 is 27, so a negative 27c. And 3 times 85, I have no clue what that is equal to. 85 times 3, and it's going to be a negative 255. So let's do this one. 4 times 15 is 60, but it's a negative 60b. 4 times 8 is a negative 32c, and negative 4 times 10 is a negative 40. So now we can add the two equations together. Our b's cancel out, which is what we wanted. Negative 27 plus negative 32 gives us a negative 59C, and negative 55 or 255 plus negative 40 is a negative 295. And at this point, we really hope that when we divide it through, it turns into a whole number. Otherwise, we've screwed something up. So 259 divided by 59, and it turns out to be a positive 5. So we're happy because it's a whole number, and we want to put it back into both of these equations to see if it actually works. So I'm not going to put it back into the equations that have the fractions. That would just be painfully annoying. I'm going to put it into 20b, take away 9 times 5 equals negative 85. So 20b, take away 45 equals negative 85. 20b equals 85 plus 45, negative 85. And I'm hoping that turns out to be a negative 40. So we got one answer of negative 40. Let's see what happens when we put it into the other equation. 15b plus 8 times 5 equals 10. 15b plus 40 equals 10. 15b equals 10 minus 40, which is negative 30. And b equals negative 30 over 15, which is negative 2. So something has gone horribly wrong. Let's go back and figure out what we did wrong here. Start right at the beginning. 20 over 15 is same as 4 over 3. 9 over 15, negative 85 over 15 seemed to work. Negative 20b, take away 9c is negative 85. Doesn't seem to be any problem. 20b, take away 9c equals negative 85, blah, blah, blah. Let's look at this one. 5 over 6, 15 over 18, good. 4 ninths, 8 over 18. 5 over 9, 10 over 18. Doesn't seem to be any problem. No problem with the signs. Sign, negative, negative, negative. So 60, 3 times 9 is 27, negative 27. 3 times 85, 255. 4 times 8 is 32, negative 32. 4 times 10 is 40, 40. And then negative 27, negative 32, negative 59, negative 255, negative 40, negative 295. Okay, so what happened here? 20b, take away 9 times 5 equals negative 85. negative 45, negative 85. Oh, how dumb. I didn't finish the equation up here. I got to negative 40, put a circle around it, and said, we're good to go. How dumb was that? We missed out. I missed out. B equals negative 40 divided by 20 equals negative 2. So I don't know whether watching me screw that up and have to fix it helps you in any way, shape, or form, but just goes to show how easy you can make really, really dumb mistakes and end up wondering what's wrong with the whole thing. Negative 2 and negative 2. So now we like this answer. And so our ordered number pair, instead of XY, we had B comma C. And we've decided that B is equal to negative 2 and C is equal to 5. So this would be where the two lines intersect, and that's all we're being asked to find. So let's save all that nonsense. And we'll try and save this whole thing.